Hi, I'm Bob. Good to see you today. We will continue our solutions to the exercises for Chapter 5, Consumer Welfare and Policy Analysis. We will solve the last 4 problems about the compensated consumer welfare. I used the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. The solutions are as detailed as possible. I hope they help you better understand and master the course. Here's exercise 2.6. The local swimming pool charges young members $10 per visit. If you join the pool, you can swim for $5 per visit, but you have to pay an annual fee of F. Use an indifference curve diagram to find the value of F such that you are indifferent between joining and not joining. Suppose that the pool charged you exactly F. Would you go to the pool more or fewer times than if you did not join? For simplicity, assume that the price of all other goods is $1. The indifference curve budget line diagram looks like this. The young member's budget line is L1. The optimal bundle A is determined by the tangency of L1 and the indifference curve I1. If the consumer becomes a member, her budget line rotates outward to L2 because the price of swimming visits falls. The new optimal bundle is B, the annual fee of F that makes the consumer indifferent between joining and not joining the pool shifts the new bundle line L2 downward to LCV. LCV is parallel to L2 and tangent to her original indifference curve I1. The tangency determines her optimal consumption bundle C. Bundle C represents the consumer joining the pool, while bundle A represents the consumer not joining the pool. The consumer is indifferent between bundle A and bundle C because they are on the same indifference curve I1. Comparing C with A, we find that the consumer will go swimming more after joining the pool than before. Let's find answers to exercise 2.7. The consumer spends her money on coffee and sugar, which she views as perfect complements. She adds 1 tablespoon of sugar to each cup of coffee. A cup of coffee costs $1. A tablespoon of sugar costs $0.2, and she spends $16.8 on coffee every week. Use graphs to show her compensating variation and equivalent variation if the price of sugar doubles. Discuss the relative sizes of the change in her consumer surplus, compensating variation and equivalent variation. The indifference curves for perfect complements are right angles. Bundle A is determined by her old budget line L1 and her original indifference curve I1. I1 is the highest indifference curve that touches her budget line. Bundle B is determined by her new budget line L2 and the new indifference curve that touches L2. Compensating variation is the amount of money that should be given to the consumer to make her enjoy the original utility. It shifts L2 upward until it touches I1. Bundle C, the bundle that usually represents the compensating variation, is identical to bundle A. However, in the demand curve diagram, point C and point A are not the same point. Bundle C is at the new price. It's above point A. The vertical line going through point A and point C is the compensated demand curve for compensating variation, HCV. On the other hand, the equivalent variation is the amount of money that should be taken away from the consumer to make her as bad as on the indifference curve I2. It shifts the old budget line L1 downward until it touches I2. Bundle D, the bundle that usually represents the equivalent variation, is identical to bundle B. In the demand curve diagram, however, bundle D is below bundle B because the former is at the old price. The Hicksian demand curve for equivalent variation is also a vertical line. As a result, in the corresponding demand curve diagram, the uncompensated demand curve, the Hicksian demand curve for compensating variation, the Hicksian demand curve for equivalent variation are different. The size of the compensating variation is the area of A plus B plus C. The change in consumer surplus is the area of A plus B. The size of the equivalent variation is the area of A. Because perfect complements must be normal goods, the size of CV is larger than the change in CS, which is larger than the size of EV. Please do not confuse the case in exercise 2.7 with exercise 2.4, where there is no income effect of a price change. In that exercise, the three measures of consumer welfare are identical. In this exercise, where there is no substitution effect of the price increase, the three measures of consumer welfare are not the same. The perfect complements must be normal goods, so the size of the compensating variation is larger than the change in consumer surplus, which is larger than the size of equivalent variation. When there is no substitution effect of a price change, the uncompensated Marshallian demand curve slows downward, but the compensated Hicksian demand curves are vertical lines. The compensated demand is completely insensitive to a price change. Let's do exercise 2.8. The consumer's utility function is as follows. The price of each good is $1, and his monthly income is $4,000. His firm wants him to relocate to another city where the price of Q2 is $3, but the price of Q1 and his income remain constant. Obviously, he would be worse off due to the move. What would be his equivalent variation and compensating variation? The utility function is for perfect complements. From the last exercise, we know that the size of the compensating variation must be larger than the size of the equivalent variation for a price increase. We can directly compute the values in this exercise. In the first step, we calculate the optimal quantities demanded before and after the price change. In bundle A, the quantities of both goods are 2,000. In bundle B, the quantities of both goods are 1,000. In the second step, we compute the compensating variation using the expenditure functions. The compensating variation is the amount of money that should be given to the consumer to make her as good as on the original indifference curve. It shifts the new budget line L2 upward until it touches the original indifference curve I1. The imaginary budget line LCV represents the compensating variation. After receiving the compensating variation, the consumer can afford bundle A at the new prices. So we have this equation. The expenditure for bundle B plus the compensating variation equals the expenditure for bundle A. Both expenditures are at the new prices. The expenditure for bundle A is $8,000. The expenditure for bundle B is $4,000. Therefore, the compensating variation is $4,000. In the third step, we compute the equivalent variation. The equivalent variation is the amount of money that should be taken away from the consumer to lower her utility so that she is as bad as on the new indifference curve. The equivalent variation shifts the old budget line L1 downward until it touches the new indifference curve I2. The imaginary budget line LEV represents the equivalent variation. After taking away the equivalent variation, the consumer can only afford bundle B at the old prices. The equation that relates expenditures and the equivalent variation is as follows. The expenditure for bundle A minus the equivalent variation equals the expenditure for bundle B. Both expenditures are at the old prices. So the equivalent variation is $2,000. Let's solve exercise 2.9. The consumer's utility function is linear. The price of each good is $1, and her monthly income is $4,000. Her firm wants her to relocate to another city where the price of Q2 is $2. But the price of Q1 and her income remain constant. What would be her equivalent variation or compensating variation? The linear utility function is for perfect substitutes. Before the price change, her old budget line was L1. The indifference curve has the same slope as the budget line. They overlap each other. The optimal quantities are that the sum of Q1 and Q2 is 4,000. So the old utility level is 4,000. After the price change, the optimal bundle is B, where is the corner solution the highest possible indifference curve that touches the new budget line L2. The consumer spends her entire income on Q1. She purchases 4,000 units of Q1 and 0 of Q2. Her new utility is still 4,000. Her utility level remains unchanged after moving to another city, so the compensating variation and the equivalent variation are both 0. From the last two videos, we can make a summary of the measures of consumer welfare. When there is no income effect of a price increase, the three measures are equal to each other. When there is no substitution effect of a price increase, the size of compensating variation is larger than the change in consumer surplus, which is larger than the size of equivalent variation. For a price increase of a normal good, the size of CV is larger than the change in CS, which is larger than the size of EV. For a price increase of an inferior good, the opposite order holds. Thank you so much for solving the exercises with me today. See you tomorrow in the next part of Chapter 5. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.